Hello, everyone. Thank you for joining us in this session of Spokane Public Schools Keep Learning series for mathematics. Today's lesson is for students in grade 5, but all of you are welcome to join in. My name is Mrs. Henshin, and I'm a 5th grade teacher at Logan Elementary in Spokane Public Schools, and I will be your teacher for this lesson. I'm so glad you are participating with me today. For today's lesson, you are going to need something to write on and something to write with. So take a moment and gather those supplies right now. Okay, are you ready? Today's learning target is I am learning to multiply decimals using an area model. Before we get into that, let's do a quick review of exponents. So I'm going to have you fill in this chart on your own, and then we'll come back together and we'll check our answers. Go ahead, try it out now. So how did you do? Let's take a look. So we already had the first row done for us. 10 is the standard form, 10 is the factor form, and 10 to the first power is the exponential form. For 100, it would be, right, 10 times 10, and that's 10 to the second power. So what if we have 10 times 10 times 10? What's the standard form? 1,000. And the exponential form is 10 to the third power. For 10,000, we would have 10 times 10 times 10 times 10. And the exponential form is 10 to the fourth power. For 100,000, 10 times 10 times 10 times 10 times 10, and that's 10 to the fifth power. How many did we have down here? 1, 2, 3, 4, 5, 6. So 10 times 10 times 10 times 10 times 10 times 10 is 1 million, or 10 to the sixth power. Great job on that review. Let's go ahead and move on. Sarah solved the problems below and got all the answers correct. What patterns are you noticing? What's really happening to the product? Okay, if there's someone near you, I want you to take a second and discuss. What patterns are you seeing? Now, if not, you can just write it down. Go ahead and do that now. Okay, maybe you said something like this. When multiplying a whole number by a power of 10, there are the same numbers of zeros in the products as there are in the exponent. So let's take a look at that. 1 in the exponent, 1 0 in the product. 2 as the exponent, 2 zeros. 3, 3 zeros. 4, 4 zeros. True. But what's really happening to that product? Are we adding zeros? Of course we're not adding 0, because if we add 0, it doesn't change our answer. The answer here is getting 10 times bigger. Here, it's getting 10 times 10 times bigger, so 100 times bigger, and 1,000 times bigger, and 4,000 times bigger. Okay, now I want you to think about this. Is this going to work for decimals? Will it look different or the same? What do you think? Tell the person near you or write it down. Well, let's check it out. 7 6/10 times 10 to the first power. Write down, what do you think the answer is? Go ahead. 76, right. 7 6/10, 10 times larger, is 76. How about 7 6/10 times 10 to the second power? Write it down. 760. Good. 7 6/10 times 10 to the third power. Write it down. Did you say 7,600? Okay. What about if we change it to 7,600 times 10 to the first power? 7 6/10. Good. How about 7,600 times 10 to the second power? 76? Awesome. One more. 7,600 times 10 to the third power. 760, right. So is it the same with decimals as it was with whole numbers? Do I have the same number of zeros in my answer? Nope, not this time, because this exponent says 2, but I have 1 0. This exponent says 3, but I have 2 zeros. So when I have decimals, what really happened is that it shifted 10 times larger. This time it shifted 10 times larger, and then another 10 times larger. Awesome job. Okay, let's try multiplying some other decimals times whole numbers. 1/10 times 43. See if you can figure this one out. Try it out. I was thinking that it might help to look at it like multiplying fractions by whole numbers. I know a couple weeks ago you worked really hard on that. Now we're not going to use an area model. We're just going to look at the numbers. So that's like saying 1/10 times 43, or 1/10 times 43 over 1. Same thing, 43 wholes. Okay, that's 43 tenths. Now if 10 tenths makes 1 whole, then 20 tenths would make 2, 30 tenths would make 3, and 40 tenths would make 4 wholes, and we'd have 3 tenths left over. 4 and 3 tenths. And we can write that as a decimal, 4.3, 4 and 3 tenths. Good. Okay, what about 2 tenths times 43? Try that one out. Maybe you'll notice a pattern between these two. Did you say 8 and 6 tenths? Remember number strings maybe back in your classroom. If one of the factors doubles and the other one stays the same, then the product doubles. 4 and 3 tenths doubled is 8 and 6 tenths. Good. Okay, what about this one? 10 hundredths times 4 and 3 tenths. Try that out. Did you say 43 hundredths? Nice work. Okay, last one. 20 hundredths times 4 and 3 tenths. Look closely. You may find a similar connection that you did up here in these two problems. Try it out. Okay, did you say 86 hundredths? Nice work. So what's the connection? This factor doubled and this one stayed the same, just like above. When one factor doubles and the other stays the same, then the product doubles. 43 hundredths doubled is 86 hundredths. Okay, now we're going to look at the area model we've been talking about. Notice this one is open. It doesn't have all the grid lines like in our last lesson. Let's read the problem. Ramona, her brother Pablo, and their dad are planning to build a deck in the backyard. Here is their plan. So how are you going to go about solving this? Talk it over with someone near you. Okay, for area, that's what we're looking for. We want to find the area of their deck. We always multiply length times width. So 2 meters times 4 and 7/10 meters. But notice up top, they broke it down into 4-meter section and then a 7/10 meter section. So first we can just multiply 2 times 4, 8. And then we have to multiply 2 times 7/10. Now I was thinking we could just split up this 2-meter section into 1 meter and 1 meter. And 1 times 7/10 is just 7/10. And then again, 1 times 7/10 is just 7/10. And you could add them together. And you'd have 1 and 4/10. Okay, so 2 times 7/10. Let's look at it like fractions. 2 times 7/10, that's 14/10. And 10/10 makes 1 whole, and we'd have 4/10 left over. Written as a decimal, it's 1 and 4/10. Okay, now what? We have the two partial products, so we need to add them together. A plus 1 and 4/10 equals 9 and 4/10 meters squared. Remember to label, we're talking about square meters. The other thing you could do is do meters squared with an exponent of 2. Next problem. They discovered that they have a little more space than they thought, and they can make the deck 2 and 3/10 meters wide instead of just 2 meters. Add to your sketch or make a new one to model and find the area of the wider deck. So we drew it out here for you. Let's just do the multiplication. Try this one out on your own. Go ahead. Okay, I'm going to start by multiplying 2 times 4, and that gave me 8. And the 2 times 7/10 is 1 and 4/10. Those were all from the last problem, so we are already ready and knew that. 2 times 4 is 8. 2 times 7/10 is 1 and 4/10. Now the new part, we have this 3/10 section times 4. Again, I was thinking I could break this up into little 1-meter sections. And then each one, 3/10 times just the 1 is 3/10. Okay, so 3/10 plus 3/10 plus 3/10 plus 3/10, 1 and 2/10. It's 12/10, right? 1 and 2/10. Okay, last section. We have a 3/10 side times a 7/10 side. 21 hundredths. Okay, let's look at that in fraction form. 3/10 times 7/10. 3 times 7 is 21. 10 times 10 is 100. So 21 hundredths. That was our last step. Now we have 4 partial products. What do we need to do? Add them all up. Okay, 8 plus 1 and 4/10 plus 1 and 2/10 plus 21 hundredths is 10 and 81 hundredths. And then don't forget to label meters squared. You could also do the little 2 for an exponent. Okay, last one on this open area model. Andre, Raven, and their mom are building a deck in the backyard. Here is a sketch of their deck, and it wants us to find the area in square meters once again. Okay, so the problem we're trying to solve is 2 and 5/10 meters times 6 and 7/10 meters. This time, I'm going to start down in this corner and work back A, B, C, D. If you can remember back when we were in our classrooms, when we were first learning the standard algorithm for multiplication, but we started with this area model like this. It just really reminded me of that. So that's how I'm going to do it this time. Go ahead and try to solve it on your own any way you would like first. Go ahead. Okay, that's a lot of work. It's okay if you're not quite there. Let's start working it out together. So first, I wanted to multiply the 5/10 times the 7/10, 35 hundredths. Okay, and then I was going to go to the next section. 5/10 times 6 is 3. Okay, so the next thing we have to do is 7/10 times 2. 7/10 times 2 is 1 and 4/10. And then the last one is 6 times 2, or 2 times 6, and that's 12. Final step, we add all of the 4 partial products together. 3 and 0 is 3. 3 plus 0 plus 4, 7. 3 plus 1 plus 2, 6. 16 and 75 hundredths. Now, remember, we're talking about square meters, so always be sure to label your answer. 16 and 75 hundredths square meters.
Okay, so here is the area model that we just did with the PowerPoint. Right here, we had our 4 partial products. We added them all up, and we got our final product of 16 and 75 hundredths. So now we're going to work on this same problem, but doing the standard algorithm. One great thing to do when you're doing the standard algorithm with decimals is to make an estimate first, because you'll see it's going to help you decide where to put your decimal point when you're done. Okay, so I'm thinking 6 and 7/10, that rounds up to 7, and 2 and 5/10 rounds up to 3. So 7 times 3 is 21. So our estimate is going to be about 21. Our answer should be about 21. Now we rounded both of them up, so our actual product is going to be smaller than 21, right? Okay, so one thing you can also do when you're multiplying decimals using the algorithm is just to think of each number as a digit rather than 5/10, 7/10, and then using this estimate, like I said, to help you place that decimal point. So if you know the steps of the algorithm really well, you're going to do awesome. So here we go. 5 times 7 is 35. Okay, but really, you're thinking about this, it's 5/10 times 7/10 is 35/10, and 35/10 is the same as having 3 wholes and 5/10, and that 3 is now over in that ones place. Okay, all right. Then we move over and we do 5 times 6. 5 times 6 is 30, plus 3 more, 33. And then what do we put here? Placeholder 0, because we're no longer multiplying in the tenths. We're now moving over to the ones. Okay? 2 times 7, 14. And 2 times 6 is 12, plus 1 more, 13. And the last step in our algorithm is to add it all together. 7, 6, 1. Now, I know you know where to put the decimal point because we already did it, right? But let's think about it. How does this estimate help me know where to put it? Would I put it here? 1 and 675 thousandths? Is that anywhere near 21, which was our estimate? No, that's not reasonable, right? Or if we put it here, 167 and 5 tenths, is our estimate anywhere near the hundreds? No. So, logically, our decimal point should go here. 16 and 75 hundredths. Do you see how our estimate helps us place the decimal point? Okay, are you noticing anything else about the product and the factors? About the decimal point anywhere in there? Did you notice that there are 2 places to the right of the decimal point in our product, and there are also 2 places to the right of the decimal point in our factors? Yeah, that can also help you place the decimal point. Now, how about, do you notice anything between our 2 partial products and our 4 partial products? If there's someone with you, why don't you chat about that now? If not, write down something. What are you noticing between the 2 partial products and the 4 partial products? Okay, in the 4 partial products, do you see those numbers up there anywhere? Right here. How many of you saw that? If you add these 2 together, because now we know our decimal is here, right? If you add these 2 together, you get 3 and 35 hundredths if you add these together. Now what about this one? They're right here. 13 and 40 hundredths. 13 and 40 hundredths. Okay? Isn't it great how both of these work, and you can really compare them and see where you got those numbers from. Nice job working on the standard algorithm. Make up someone your own and practice this standard algorithm, but make sure you do that estimate first so you know where to place your decimal point.
Here is today's assignment. Make sure you connect with your teacher on how they want you to turn this in. Number 1, a certain computer chip measures 44 hundredths by 44 hundredths inches. What is the total area of the computer chip? And then we have some mixed multiplying problems by 1/10. And then for number 3, the city park measures 1 2/10 kilometers by 63 hundredths kilometers. Estimate the total area of the park for A, and for B, make a labeled sketch of the park and use it to calculate an exact answer. Okay, I'm going to give you a little bit of time to get this copied down. Go ahead. Okay, I've enjoyed doing some mathematics with you today. Thank you for joining me as you continue your learning from home. I look forward to seeing you again for our next lesson on KSPS.